Hello, Professor. I'm recording my lecture like I wrote because today is the last day and I don't want to miss it after the work I did. So eventually, I did not run it with different threads. I kind of did everything in one thread because I was struggling a bit. So it's like going like serial kind of way. Um, okay, so now I will present how I exactly did it. Okay, just a second. Okay, so this is the final project by me, Eden O'Leary, to using all the scheduler algorithms, the FCFS, the OR, the SJF, and the SRTF. And now I present it. So this is my struct process that includes the process ID, that's an integer, and obviously everything here is integers, the arrival time. There are the burst time, the end time, and the remaining time that I will be using. And the first one that I implemented was the first come, first serve, and the FCFS. And what it does actually is that this scheduling algorithm, it works by the arrival time, and if one process comes early, so the processor will process it until it's finished, and then the processor will process in a chronological order. So this is my code for the FCFS ones, and like what you can see here, the first while goes along as there goes the first while goes as long as there are like still processes available, and it will go through each process every time. And then the for loop over here, it searches for the first from all the other that were not there like by the while loop, and it goes to do it. And then the next while loop here, it checks if we arrive to the arrival time of the process and prints ideal until it getting there. And then this for loop, what it does actually, it runs itself and prints it until we're done with everything here. You can look at it in the code that I will send you with everything, and basically everything kind of looking like the same idea as the FCFS that I just said. And the next scheduling algorithm is the round robin, and what the round robin does is put processes into a queue by arrival time at first, and then starts with the first process. The processor will process a process for a limited time that will be quantum, that can be decided by me or by the user or anything. And by the time, if it is not finished, the process will be paused, and the processor will put it into the end of the queue and process next process, and we do it again and again until finished. So this is my round robin code over here, like you can see. It's attached to the code so you can see it better, or you can stop the video to just see it again. I know it's very different than what you expected and probably what other people did, but this is what I've been managed to do with my knowledge and the help that I got. Okay, so now with the SJF, the shortest job first, that's actually a non-preemptive one. That's a non-preemptive policy in which the process with the shortest expected processing time is the one that's selected next. And this is my code for the shortest job first. Over here, like you can see, it was kind of the same idea with obviously the changes that goes with it. I guess you can just stop the video to look again, like I said. And then the next one, the last one that I implemented, is the shortest remaining job first. That's also a preemptive one, and the scheduler always choose the process that has the shortest expected remaining processing time. And one is this one. So here's the code. Yeah, here's the second part, and now for the graph. This is the graph that I managed to do. It shows the average turnaround time for one of the inputs that I put it. So this was the average turnaround time in seconds for the FCFS. Like you can see, it was almost 10 seconds. The round robin was the longest one out of them when the quantum was 2. There is the short jump force with 8, and the SRTF was actually the shortest one with average turnaround time out of everything. And when it came to average waning time, and the FCFS is the longest one with 6.5 seconds. Then the round robin with the shortest one of 2 seconds, which makes sense according to round robin. The shortest jump first with almost 5 seconds and average time, and the SRJF that will show that's it at like 4 seconds. And now we show the code as well, and the other one.